Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have two circles. Each circle is passing through the center of the other circle. We know that the radius of one circle, or the radius of each circle, is equal to 5 units, and we want to find out the area of this green shape. But first of all, I will present to you what is a sector. A sector is the area that is bounded by the two radiuses and the arc that is between those two radiuses. Okay, the area that is bounded between those two radiuses and the arc that is included between those two radiuses is the sector, and the area of a sector is equal to pi r square, when r is the radius of the circle, so it is pi r square times the angle that is the angle between the two radiuses over 360 degrees. In this case, the angle between those two radiuses is 60 degrees, so it is pi r square times 60 degrees over 360 degrees. So this is the definition of a sector. We have also the term segment. Segment is the area that is bounded by the arc and the chord that is attached to that arc. So here, segment AB is the area that is bounded by arc AB and chord AB. And the area of segment AB equals to the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB equals to the area of segment AB. Okay? So, in the next step, we will define the center of this circle as point P, and we will define the center of this circle as point Q, and we will define the first intersection point of those two circles as point A, and we will define the second intersection point of those two circles as point B. We will join points P and B together by a straight line. Line segment PB is the radius of this circle because of the fact that line segment PB starts from point P, that is the center of this circle, and ends at point B, that is a point on this circle itself. Therefore, it is the radius of this circle, that is to say, it equals to 5 units because of the fact that the radius of each circle equals to 5 units. We will join points B and Q together by a straight line. Line segment QB is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point Q, and ends at point B, that is a point on this circle itself. Therefore QB is the radius of this circle, that is to say it equals to 5 units. We will join points A and P together by a straight line. Line segment AP is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point P and ends at point A, that is a point on this circle itself, therefore it is the radius of this circle, that is to say it equals to 5 units. We'll join points A and Q together by a straight line. And again, line segment AQ is the radius of this circle because of the fact that it starts from the center of this circle and ends at point 8. It is the point of this circle itself, therefore it is the radius of this circle, that is to say it equals to 5 units. So here we created a rhombus APBQ. Any quadrilateral that has 4 equal sides, like here, it is defined as a rhombus. So quadrilateral APBQ is a rhombus. I'll write it down. Quadrilateral APBQ is a rhombus. A rhombus is a quadrilateral that has 4 equal sides. So quadrilateral APBQ is a rhombus. Here we join points A and B together by a straight line. AB, line segment AB, is the first diagonal of rhombus APBQ, and we'll join points P and Q together by a straight line. Line segment PQ is the second diagonal of this rhombus APBQ. PQ is also the radius of this circle because of the fact that it starts from the center of the circle and ends at point Q, that is a point on this circle itself. Therefore PQ is the radius of this circle, that is to say PQ equals to 5 units. So we have here 2 diagonals, diagonal AB and diagonal PQ of rhombus APBQ, and we have 2 characteristics of the diagonals of a rhombus. I write it down. The 2 characteristics of the diagonals of a rhombus The first characteristics of the diagonals of a rhombus is that they are perpendicular to each other. So here, diagonal AB and diagonal PQ are perpendicular to each other. That is to say, we have here 4 right angles But before that, we define the intersection point between diagonal AB and diagonal PQ as M. So the diagonals of a rhombus are perpendicular to each other. That is to say, we will have here 4 right angles. And the second characteristic of the diagonals of a rhombus is they bisect each other. They bisect each other. The diagonals bisect each other. Bisect each other. Okay, so the diagonal AB bisect diagonal PQ, that is to say PM equals to MQ. PM equals to MQ. And we also know that the diagonal PQ bisects diagonal AB, that is to say AM equals to MB. AM equals to MB. So we know that PM equals to MQ. So if we define PM as X, then MQ will be also equal to X because of the fact that they are equal to each other. So PQ equals to X plus X. X plus X equals to PQ. X plus X equals to PQ. X plus X is 2X, and 2X equals to PQ. 2X equals to PQ. But we already found out that PQ equals to 5 units, so we can write here that PQ equals to 5. So from this equation we will derive that 2x equals to 5. 2x equals to 5. Here we will divide this equation by 2 and we will get that x equals to 5 over 2 units. So we can substitute x by 5 over 2. Here PM that equals to x will be equal to 5 over 2 units. And here MQ that equals also to x will be equal to 5 over 2 units. So in the next step we will focus on the right triangles APM, triangle PBM, triangle QBM, and triangle AQM. Okay, so I write it down. We will focus on the right triangles. Triangle APM, triangle PBM, triangle QBM, and triangle AQM. So on those 4 right triangles, if you focus on those angles, then we can write down that cosine of those 4 angles, cosine of those 4 angles will be equal to 5 over 2 over 5. 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 Okay, so cosine of those 4 angles will be equal to 5 over 2 over 5. Here 5 over 2 over 5 is 5 over 5 times 2. 5 over 5 is 1. So in conclusion, we found out that cosine of those four angles equals to 1 over 2. And if cosine of an angle is equal to 1 over 2, it means that the angle itself is equal to 60 degrees. So the four angles are equal to 60 degrees. Each of them are equal to 60 degrees. So we can write down that angle APM is equal to 60 degrees. Angle BPM is equal to 60 degrees. Angle BQM is equal to 60 degrees. And also angle MQA is also equals to 60 degrees. Okay. In the next step, we will prove the triangle APB is congruent to triangle ABQ. I will write it down. Triangle APB. This triangle congruent to triangle AQB. So, why those two triangles can go into each other? First of all, we know that AP equals to PQ. AP equals to PQ. And they are both equal to 5 units. We also know that PB equals to BQ equals to 5 units. And AB is a common side, it belongs to both triangles, so we can write down that AB equals to AB. It's a common side that belongs to both triangles. Okay, so we actually proved the triangle APB can go into triangle AQB according to side rule. So triangle APB congruent, this is the sign for congruent, to triangle AQB according to side rule. Okay, those two triangles can go into each other according to side rule. All the sides of triangle APB can go into all the sides of triangle AQB, therefore those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that they also have the same areas. That is to say, the area of triangle APB is equal to the area of triangle AQB. Okay. The areas of those two triangles are equal to each other. So I write it here that the area of triangle APB is equal to the area of triangle AQB. what is the area of sector APB? The area of sector APB will be equal to pi r square times 120 degrees over 360 degrees. Pi r square times 60 degrees plus 60 degrees is 120 degrees over 360 degrees. I repeat again, the area of sector APB equals to pi r square times 120 degrees over 360 degrees. Here r equals to 5 units, so r square is 25. So in the numerator we have 25 and 25 pi and 120 degrees over 360 degrees is 1 over 3. So in conclusion, we found out that the area of sector APB is equal to 25 pi over 3 square units. And what is the area of sector AQB? The area of sector AQB equals to pi r square times 120 degrees over 360 degrees equals to pi r square over 120 degrees over 360 degrees. And r equals to 5, so r square is 5 square, 5 square is 25, so it is 25 pi, and 120 degrees over 360 degrees is 1 over 3. So we found out that the area of sector AQB is also equals to 25 pi over 3 square units. So both of the areas of sector APB and sector AQB are equal to 25 over 3 square units. Therefore, we can conclude that the area of sector APB is equal to the area of sector AQB. Okay. And they are equal to 25 pi over 3 square units. And we also know that the area of triangle APB equals to the area of triangle AQB. So we define the area of triangle APB as x, and therefore the area of triangle AQB will be also equal to x. So according to our definition, the area of triangle APB that equals to the area of triangle AQB equals to x square units. And what is the area of segment APB? The area of segment APB the area of this segment APB will be equal to the area of sector AQB minus the area of triangle AQB. I'll repeat again. The area of segment APB will be equal to the area of sector AQB minus the area of triangle AQB. Okay? And so, but we have already found out that the area of sector AQB is equal to 25 pi over 3 square units, and the area of sector and the area of triangle AQB is equal to x according to our definition. So in conclusion, we found out that the area of segment APB equals to 25 pi over 3 square units minus x square units. Again, the area of segment APB equals to 25 pi over 3 minus x square units. And what is the area of segment AQB? The area of segment AQB the area of segment AQB, this segment will be equal to the area of sector APB minus the area of triangle APB. Equals to the area of sector APB minus the area of triangle APB. I'll repeat again. The area of segment AQB equals to the area of sector APB minus the area of triangle APB. But we have already found out that the area of sector APB equals to 25 pi over 3 square units, and the area of triangle APB equals to x according to our definition. So in conclusion, we found out that the area of segment AQB equals to 25 pi over 3 minus x square units, exactly as the area of segment APB, that is also equals to 25 pi over 3 minus x square units. Therefore, we will conclude from those two equations that the area of segment APB is equal to the area of segment AQB. Okay? The area of segment APB equals to the area of segment AQB. The area of segment APB is equal to the area of segment AQB. Therefore, the area of the green shape will be equal to the area of segment APB times 2. Okay? The area of the green shape will be equal to the area of segment APB times 2. I repeat again, the area of the green shape equals to 2 times the area of segment APB. And we have already found out that the area of the green shape equals to so we already found out that the area of segment APB is equal to the 25 pi over 3 minus x. So the only missing variable that we have here is x. And x is the area of triangle APB. X equals to the area of triangle APB. So we'll find out the area of triangle APB, that is x, and 2 times 25 pi over 3 minus the area of triangle APB will be equal to the area of the green shape. So the area of triangle APB, will be equal to the base of the triangle, that is AB, times the height to the base, that is PM, over 2. I'll repeat again, the area of triangle APB will be equal to the base of the triangle, that is AB, times the height to the base, that is PM, over 2. Okay? So, what is the value of AB? We already know that AM equals to MB. So, if we define AM as edge, then MB will be also equal to edge. And if we focus on triangle AQM, on the right triangle AQM, here sinus 60 degrees will be equal to edge over 5. I will repeat again. In the right triangle AQM, sinus 60 degrees equals to edge over 5. We'll multiply this equation by 5 and we get that edge equals to sinus 60 degrees times 5. Sinus 60 degrees equals to square root of 3 over 2 times 5. So we found out that edge equals to square root of 3 over 2 times 5. So here edge equals to square root of 3 over 2 times 5. And then also edge equals to square root of 3 over 2 times 5. Therefore, AB equals to edge plus edge. That is to say, AB equals to 2 edge. AB equals to 2 edge. That is to say, it equals to 2 times edge is square root of 3 times 5 over 2. Here, 2 over 2 is 1. So we found out that AB equals to square root of 3 times 5. AB equals to square root of 3 times 5. So here the area of triangle APB will be equal to AB, that is square root of 3 times 5, times PM. PM equals to 5 over 2 units, 5 over 2, all divided by 2. So here we got that the area of triangle APB that equals to x actually equals to 5 times 5 is 25. So the numerator we have 25 times square root of 3 over 2 times 2 is 4. Okay, so x equals to 25 times square root of 3 over 4. And the area of the green shape equals to 2 times 25 pi over 3 minus x. So it is actually equals to 2 times 25 pi over 3 minus x, and x equals to 25 times square root of 3 over 4. So here we take 25 out as a common factor of those two expressions, and we will get that the area of the green shape equals to 50, and here we took 25 as a common factor out of this expression. So what is left inside the brackets? What is left, it is actually pi over 3 minus, so we took from this expression 25 as a common factor, so what left from it after we took from it 25 as a common factor, what is left, it is actually square root of 3 over 4. Okay? So, in conclusion, we found out that the area of the green shape equals to 2 times 25 is 50 times pi over 3 minus square root of 3 over 4 square units. I repeat again, we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will do the same constructions as we did in the first method, but first of all, we will define the center of this circle as point P. We will define the center of this circle as point Q. We will define the first intersection point between those two circles as point A. And we will define the second intersection point of those two circles as point B. Then we will join points P and B, B and Q, and A and Q, A and P by a straight line as we did in the first method. We already found out that all the line segments here are equal to 5 units, so I'll not repeat on it. We join together points P and Q by straight line. We've already found out that PQ equals to 5 units. So here we actually have two equilateral triangles. Triangle APQ is an equilateral triangle because of the fact that all of its sides they are equal to each other, they are equal to 5 units. Therefore, all of its angles will be equal to 60 degrees. It's an equilateral triangle. Triangle PQB is also an equilateral triangle because of the fact that all of its sides are equal to each other, they are equal to 60 degrees. And actually, the equilateral triangle APQ is congruent to the equilateral triangle PBQ according to side rule. I write it down. The equilateral triangle APQ is congruent to the equilateral triangle PBQ according to side rule. Okay. All the sides of triangle APQ congruent to all the sides of triangle PBQ, they are all equal to 5 units. And from the fact that those two triangles congruent to each other, we'll conclude that they have also the same areas. So the area of triangle APQ equals to the area of triangle PBQ. The area of triangle APQ is equal to the area of triangle PBQ. So those two equilateral triangles have the same areas. Therefore, the area of the green shape will be equal to 2 times the area of triangle APQ. The area of the green shape will be equal to 2 times the area of triangle APQ plus the area of segment AP plus the area of segment PB plus the area of segment AQ plus the area of segment QB. I repeat again, the area of the green shape will be equal to 2 times the area of the equilateral triangle, triangle APQ, plus the area of the 4 segments, segment AP, plus the area of segment PB, plus the area of segment AQ, plus the area of segment QB. Okay? So what is the area of triangle APQ? We will join points A and B together by a straight line. We define the intersection point between AB and PQ as point M. We have already found out in method 1 that AM equals to 5 times square root of 3 over 2. And we know that PQ equals to 5 units. It is written here. So the area of triangle APQ, this triangle, the equilateral triangle, triangle APQ, will be equal to the base of the triangle, that is PQ, times the height, that is AM, over 2. I will repeat again. The area of the equilateral triangle, triangle APQ, will be equal to the base of the triangle, that is PQ, times the height, that is AM, over 2. Okay, so here PQ equals to 5 units, AM equals to 5 times square root of 3 over 2, and we also know that AM equals to MB, so here it is also 5 times square root of 3 over 2, and here all divided by 2. So here we have 5 times 5 is 25, times square root of 3 over 2 times 2 is 4. So we actually found out that the area of triangle APQ is equal to 25 times square root of 3 over 4. So here we can write down that the area of triangle APQ equals to 25 times square root of 3 over 4 plus the area of segment AP. What is the area of segment AP? The area of segment AP So here, the area of segment AP equals to the area of sector AQP minus the area of triangle AQP, equals to the area of sector AQP minus the area of triangle AQP. I repeat again, the area of segment AP equals to the area of sector AQP minus the area of triangle AQP. And the area of sector AQP equals to pi r squared times 60 degrees over 360 degrees, pi r squared times 60 degrees over 360 degrees, minus the area of triangle AQP. The area of triangle AQP, we already found out that the area of triangle AQP equals to 25 times square root of 3 over 4. So in conclusion, so what is R? R is 5, so R square is 5 square. 5 square is 25, so in the numerator we have 25 pi, and 60 over 360 is 1 over 6. So it is 25 pi over 6 minus 25 times square root of 3 over 4 square units. So in conclusion, we found out that the area of segment AP equals to 25 pi over 6 minus 25 times square root of 3 over 4 square units. So we found out the area of segment AP. In the next step, we will find out the area of segment PB. What is the area of segment PB? The area of segment PB So the area of segment PB will be equal to the area of sector PQB minus the area of triangle PQB. So the area of sector PQB minus the area of triangle PQB. What is the area of sector PQB? The area of sector PQB, this sector will be equal to pi r squared times 60 degrees over 360 degrees. It equals to pi r squared times 60 degrees over 360 degrees minus the area of triangle PQB. Minus the area of triangle PQB, we already found out that the area of triangle PQB equals to the area of triangle APQ. And the area of triangle APQ equals to 25 times square root of 3 over 4. So here R equals to 5, so R squared is 25. So we have here this expression equals to 25 pi over 6 minus 25 times square root of 3 over 4. So the area of segment PB equals to 25 pi over 6 minus 25 times square root of 3 over 4, exactly like the area of segment AP, that is also 25 pi over 6 minus 25 times square root of 3 over 4. So from these two equations, we will conclude that the area of segment AP is equal to the area of segment PB. Again, the area of segment AP equals to the area of segment PB, and if we continue to calculate the area of segment QB and the area of segment AQ, we will get that the area of those two segments, they are also equal to this expression, and we will conclude that the area of all four segments, they are equal to each other, and they are equal to this expression, that is the area of segment AP, that is actually 25 pi over 6 minus 25 times square root of 3 over 4. So the area of the sum of the areas of those four segments, segment AP, segment PB, segment QB, and segment AQ, will be equal to 4 times the area of segment AP. Okay? So the area of the green shape, will be equal to 2 times the area of triangle APQ that is actually equals to 25 times square root of 3 over 4 plus 4 times the area of segment AP. I'll repeat again. The area of the green shape equals to 2 times the area of the equilateral triangle APQ plus 4 times the area of segment AP. Okay, and we have already found out that the area of segment AP equals to 25 pi over 6 minus 25 times square root of 3 over 4. So, in conclusion, the area of the green shape equals to 2 times the area of triangle APQ, that is 25 times square root of 3 over 4, plus 4 times the area of segment AP, that equals the area of the segment AP equals to 25 pi over 6 minus 25 square root of 3 over 4. So here we will multiply this equation by 2 and we will open the brackets here and we will get that 2 times 25 is 50 times square root of 3 over 4 plus 4 times 25 is 100, so we will have here 100 times pi over 6 minus 4 times 25 is minus 100 square root of 3 over 4. So here 50 times square root of 3 over 4 minus 100 times square root of 3 over 4 is equal to minus 50 times square root of 3 over 4. And here we have 100 pi over 6. We divide both the numerator and the denominator by 2 and we get that 100 over 2 is 50. So it is 50 pi. 6 over 2 is 3. So we found out that the area of the green shape equals to 50 pi over 3 minus 50 times square root of 3 over 4. Here we will take 50 as a common factor out of those two expressions and we get that, so 50 is taken out as a common factor, so what is left from 50 pi over 3 after we took from it 50 as a common factor, what is left, it is actually pi over 3, and what is left from minus 50 square root of 3 over 4 after we took from it 50 as a common factor, what is left, it is actually square root of 3 over 4. So in conclusion, we found out that the area of the green shape, according to the second method, is equal to 50 times pi over 3 minus square root of 3 over 4, exactly as we found in the first method. So in the next step, I will summarize this lecture. So we actually wanted to find out the area of this green shape and we have here two circles. Each circle is passing through the center of the other circle. We know that the radius of each circle is equal to 5 units, and we want to find out the area of this green shape. First of all, I explained what is a sector. A sector is the area that is bounded by those two radiuses and the arc AB that is included between those two radiuses. Again, the area that is bounded by two radiuses and the arc that is included between those two radiuses is defined as a sector, and the area of any sector is equal to pi r squared times the angle between the two radiuses over 360 degrees. In our specific case, the angle between the two radiuses AO and OB is 60 degrees, so the area of this specific sector will be equal to pi r squared, when r is the radius of this circle, and the angle here is 60 degrees over 360 degrees. So the area of this specific sector equals to pi r squared times 60 degrees over 360 degrees. Okay, then I presented to you the definition of a segment. A segment is the area between chord AB, the area that is bounded between chord AB and arc AB. Again, the area that is bounded by chord AB and arc AB is defined as segment AB, and the area of segment AB, the formula for the area of segment AB will be equal to the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB will be equal to the area of segment AB. And the segment is the area that is bounded by chord AB and arc AB. Okay? Then we made the construction here. We joined points A and P, A and Q, P and Q, P and B by a straight line, by straight lines. AP is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point P, and ends at point A, that is a point on the circle itself. Therefore, line segment AP is the radius of this circle, that is to say it equals to 5 units. And in the same way, we will conclude that all the other segments AQ, BQ, and PB are the radiuses of those circles, that is to say they are equal to 5 units. So by drawing those 4 line segments, we created here rhombus APBQ, and the definition of a rhombus is a quadrilateral that all of its sides are equal to each other. So we can write down that rhombus APBQ or quadrilateral APBQ is a rhombus because of the fact that all of its sides are equal to each other, they are equal to 5 units. Then we join together points A and B by a straight line. AB is the first diagonal of rhombus AQBP. Then we join points P and Q together by a straight line. PQ is the second diagonal of rhombus PAQB, and PQ is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point P, and ends at point Q, that is the point of the circle itself. Therefore PQ is the radius of this circle, that is to say it equals to 5 units. PQ equals to 5 units. And we have 2 characteristics of the diagonals of a rhombus. So the two characteristics of the diagonals of a rhombus is, the first characteristic is that they are perpendicular to each other. So in this drawing, diagonal AB is perpendicular to diagonal PQ, and diagonal PQ is perpendicular to diagonal AB. That is to say, all four angles here are right angles. And the second characteristics of the diagonals of a rhombus is that they bisect each other. That is to say, diagonal AB bisect diagonal PQ. What does it mean? It means that PM equals to MQ. And we also note that the diagonal PQ bisects diagonal AB. What does it mean? It means that AM equals to MB. AM equals to MB. But because of the fact that PM equals to MB, we will define PM as X, therefore PM equals to MQ. So we'll define PM as X, then therefore MQ will be also equal to X. So we'll get that X plus X equals to PQ. X plus X equals to PQ. So X plus X is 2X. 2X equals to PQ. But we already found out that PQ equals to X. So we got here the equation that 2X equals to PQ equals to 5. From this equation we will derive that 2X equals to 5. We divide this equation by 2 and we will get that X equals to 5 over 2. So X that equals to PM equals to 5 over 2, and MQ that also equals to X equals to 5 over 2. Okay? Then we actually focused on those four right triangles, the right triangle PAM, the right triangle AQM, the right triangle BQM, and the right triangle PMB. On those four right triangles, we have four angles, 1, 2, 3, 4. So we focus on those four angles, on those four right triangles, and the value of those four angles in each triangle is cosine theta equals to 5 over 2 over 5. Here also cosine theta or cosine whatever equals to 5 over 2 over 5. Here also cosine theta equals to 5 over 2 over 5. And here also cosine theta equals to 5 over 2 over 5. So in those four triangles, we know that cosine equals to 5 over 2 over 5. 5 over 2 over 5 is 5 over 5 times 2. 5 over 5 is 1. So here cosine theta equals to 1 over 2. So we found out that cosine equals to 1 over 2. If cosine equals to 1 over 2, it means that the angle itself equals to 60 degrees. So we found out that all four angles here are equal to 60 degrees. Why? Because cosine of each angle equals to 1 over 2. That is to say, the angle itself equals to 60 degrees. All four angles are equal to 60 degrees. Then we actually proved that those two triangles can go into each other. That is to say, triangle AQB can go into triangle APB. Why those two triangles can go into each other? First of all, we know that AP equals to PQ equals to 5 units. AP equals to PQ equals to 5 units. We also know that PQ equals to BQ equals to 5 units. PQ equals to PB equals to QB equals to 5 units. Again, PB equals to QB equals to 5 units. PB equals to BQ equals to 5 units. And AB equals to itself. AB equals to AB is a current side that belongs to both triangles. AB equals to AB is a current side that belongs to both triangles. So we actually proved that triangle AQB can go into triangle APB according to side rule. All sides of triangle AQB can go into all the sides of triangle APB. Therefore, those two triangles can go into each other according to side rule. And because of the fact that those two triangles can go into each other, we will conclude that they have also the same areas. That is to say, the area of triangle APB is equal to the area of triangle AQB. Okay, so those two triangles have the same areas. Again, the area of triangle APB is equal to the area of triangle AQB. Then, what is the value of sector APB? The value of sector APB will be equal to pi r squared times 60 plus 60 is 120 degrees over 360 degrees. Again, the area of sector APB equals to pi r squared times 120 degrees over 360 degrees. R equals to 5, so r squared is 25. So in the numerator we have 25 pi, and 120 degrees over 360 degrees is 1 over 3. So in conclusion, we found out that the area of sector APB equals to 25 pi over 3 square units. The area of sector APB equals to 25 pi over 3 square units. Then we found out the area of sector AQB. The area of this sector AQB equals to pi r squared times 120 degrees over 360 degrees. The area of sector AQB equals to pi r squared times 120 degrees over 360 degrees. R equals to 5. R squared is 5 squared. 5 squared is 25. So in the numerator we have 25 pi, and 120 degrees over 360 degrees is 1 over 3. So in conclusion, we found out that the area of sector AQB also equals to 25 pi over 3 square units, exactly as the area of sector APB, that is also equals to 25 pi over 3 square units. So from that two equations, we will derive that the area of sector APB equals to the area of sector AQB, and both areas are equal to 25 pi over 3 square units. Okay? So, then we found out the area of segment APB. The area of segment APB equals to the area of sector AQB minus the area of triangle AQB. Again, the area of segment APB equals to the area of sector AQB minus the area of triangle AQB. Okay? And we have already found out that the area of sector AQB equals to 25 pi over 3, and the area of sector AQB equals to x according to our definition. Therefore, the area of segment APB equals to 25 pi over 3 minus x square units. Then we calculated the value of segment AQB. The value of this segment AQB, will be equal to the area of sector APB minus the area of triangle APB. Again, the area of segment AQB will be equal to the area of sector APB minus the area of triangle APB. Okay, and the area of sector APB is equal to 25 pi over 3, we have already found it, and the area of triangle APB equals to x according to our definition. So in conclusion, we found out that the area of segment AQB equals to 25 pi over 3 minus x square units, exactly as the area of segment APB. So from those two equations, we will derive that segment APB equals to segment AQB. Okay, segment APB equals to segment AQB. Therefore, the green area will be equal to 2 times the area of one of the segments. So it will be equal, the area of the green shape will be equal to 2 times the area of segment APB. It will be equal to 2 times the area of this segment APB. Why? Because those two segments are equal to each other. Again, the area of segment, the area of the green shape equals to 2 times the area of segment APB. So, and we have already found out that the area of segment APB equals to 25 pi over 3 minus x. And x is equal to the area of triangle AQB. So the area of segment APB equals to 25 pi over 3, 2 times 25 pi over 3 minus x. And x is the area of triangle AQB. And we have already found out that the area of triangle AQB, actually x is either the area of triangle APB, but it is also equals to the area of triangle AQB because they can go into each other. Therefore, they have also the same areas. So the area of triangle APB, x is the area of triangle APB, and the area, so x, that is the area of triangle APB, it is the area of triangle APB. It will be equal to AB, that is the base, times MP over 2. The area of triangle APB equals to the base, that is AB, times the height, that is PM over 2. And we found out that the area, that the length AB, it is actually equals to, here we calculated the value, the length AB. We focused on this triangle MPQ. In this triangle, we know that sinus 60 degrees equals to AM over 5. Sinus 60 degrees equals to AM, that is H over 5. So sinus 60 degrees, we multiply this equation by 5, and we found out that H equals to 5 times sinus 60 degrees. Sinus 60 degrees is square root of 3 over 2. So in conclusion, we found out that H equals to square root of 3 over 2 times 5. And AB equals to H plus H, that is to say AB equals to 2H. So we multiply H by 2 and we will get the value of AB. 2 times H is 2 times square root of 3 over 5. 2 times H is 2 times square root of 3 over 2 times 5. So 2 times square root of 3 over 2 times 5 times 2 is 2 over 2 is 1. So we found out that the value of AB is square root of 3 over 5. So we can write down that AB equals to square root of 3 times 5 times PM, that is 5 over 2, all divided by 2. So in conclusion, we found out that the area of triangle APB equals to 25 times square root of 3 over 4. So here x, that is actually equals to the area of triangle APB, equals to 25 times square root of 3 over 4. So here we have 2 times 25 pi over 3 minus 25 times square root of 3 over 4. So here we took 25 as a common factor out of those two expressions, and we got that the green area equals to 2 times 25, and after we took from 25 pi over 3, after we took from it 25 as a common factor, what is left inside the brackets is pi over 3, and what is left inside the brackets after we took 25 as a common factor from 25 times square root of 3 over 4, what is left, it is actually square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to 2 times 25 times pi over 3 minus square root of 3 over 4. 2 times 25 is 50. So in conclusion, we found out that the area of the green shape according to the first method equals to 50 times pi over 3 minus square root of 3 over 4 square units. Okay, this is according to the first method. Then I presented to you how to find out the area of the green shape according to the second method. According to the second method, we actually do the same construction as we did in the first method. So we know that AP equals to PB equals to QB equals to AQ equals to 5 units. And here we have triangle APQ is an equilateral triangle. Why? Because all of its sides are equal to 5 units. AP equals to PQ equals to AQ equals to 5 units. So therefore triangle APQ is an equilateral triangle. Triangle PBQ is also an equilateral triangle. And those two equilateral triangles can go into each other according to side rule. So triangle APQ can go into triangle PBQ according to side rule. All of its sides of triangle APQ are equal to 5 units, and all the sides of triangle PBQ also equal to 5 units. So they can go into each other according to side rule. And because of the fact that those two right triangles can go into each other, they also have the same areas. So the area of triangle APQ is equal to the area of triangle PBQ. Okay, so those two triangles have the same areas. And because of the fact that each triangle is an equilateral triangle, then the angles inside an equilateral triangle is equal to 60 degrees. So all the angles here are equal to 60 degrees, and all the angles inside this equilateral triangle also equal to 60 degrees. And therefore, the green area will be equal to 2 times the area of triangle APQ plus the area of the 4 segments AP, PB, BQ, and AQ. So the area of the green shape will be equal to 2 times the area of triangle APQ plus the area of segment AP plus the area of segment PB plus the area of segment AQ plus the area of segment QB. What is the area of triangle APQ? The area of triangle APQ will be equal to the base of the triangle that is PQ times the height that is AM over 2. The area of triangle APQ equals to the base of the triangle that is PQ times the height that is AM over 2. Okay? So PQ equals to 5 units, AM equals to 5 over 2. AM equals to 5 times square root, PQ equals to 5 units, AM equals to 5 times square root of 3 over 2 units. So PQ is 5, AM is 5 times square root of 3 over 2, all divided by 2. So here 5 times 5 is 25, so in the numerator we have 25 times square root of 3, 2 times 2 is 4, in the denominator we have 4. So we found out that the area of triangle APQ equals to 25 times square root of 3 over 4. Again, the area of triangle APQ equals to 25 times square root of 3 over 4. And the area of segment AP equals to the area of sector AQP. The area of segment AP equals to the area of sector AQP minus the area of triangle AQP. Again, the area of segment AP, this segment equals to the area of sector AQB minus the area of triangle AQB. Okay? It is actually the area of sector AQP, the area of segment AP equals to the area of sector AQP minus the area of triangle AQP, the area of sector AQP minus the area of triangle AQP, and the area of sector AQP equals to pi r squared times 60 degrees over 360 degrees. And we have already found out that the area of triangle AQP equals to 25 times square root of 3 over 4. And r equals to 5, so r squared is 25. So in conclusion, we found out that the area of segment AP equals to 25 pi over 6 minus 25 square root of 3 over 4. And then we found out the area of segment PB. The area of segment PB will be equal to the area of segment PQB minus the area of triangle PQB. Again, the area of segment PB will be equal to the area of sector PQB minus the area of triangle PQB. And the area of segment PQB is pi r squared times 60 degrees over 360 degrees. And the area of triangle PQB is equal to the area of triangle PQA, therefore it equals to 25 times square root of 3 over 4, and r equals to 5, so r squared is 25, so here in the numerator we have 25 pi, and in the numerator 60 over 360 is 1 over 6, so in the denominator we have 6, so this expression equals to 25 pi over 6 minus 25 times square root of 3 over 4. So we found out that the area of segment PB equals to 25 pi over 6 minus 25 times square root of 3 over 4, exactly as segment AP, that is also equals to 25 pi over 6 minus 25 times square root of 3 over 4. So from those two equations we will derive that segment AP equals to segment BB because of the fact that they have the same area. So the area of segment AP equals to the area of segment PB. And if we continue to calculate the area of segment QB and the area of segment AQ, we will get that they are equal also to this expression. Therefore, we actually can conclude that the areas of all segments are equal to each other and they are equal to this expression. So therefore, the area of the green shape equals to 2 times the area of triangle APQ plus 4 times the area of segment AP, because of the fact that all the segments are equal to, the area of all the segments are equal to each other, so we can multiply the area of one segment by 4, and in this way we'll get the area of all the 4 segments. Okay, so the area of the green shape equals to 2 times the area of triangle APQ plus 4 times the area of segment AP. The area of triangle APQ equals to 25 times square root of 3 over 4. So 2 times the area of triangle APQ equals to 2 times 25 times square root of 3 over 4 plus 4 times the area of segment AP. The area of segment AP equals to 25 pi over 6 minus 25 square root of 3 over 4. So here 2 times 25 is 50, so this expression equals to 50 times square root of 3 over 4. And here 4 times 25 is 100, so this expression equals to 100 pi over 6. And here 4 times minus 25 is minus 100, so this expression equals to minus 100 times square root of 3 over 4. So here 50 times square root of 3 over 4 minus 100 times square root of 3 over 4 equals to minus 50 times square root of 3 over 4. And here 100 pi over 6, we divided both the numerator and the denominator by 2, and we got that 100 over 2 is 50, and 6 over 2 is 3. So in conclusion, we got that the area of the green shape equals to 50 pi over 3 minus 50 times square root of 3 over 4. Here we took 50 as a common factor out of these two expressions, and what is left from 50 pi over 3 after we took from it 50 as a common factor, what is left, it is actually pi over 3, and what is left from 50 times square root of 3 over 4 after we took from it 50 as a common factor, what is left, it is actually minus square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units, exactly as we found in the first method. So in both methods, we found out that the area of the green shape equals to 50 times pi over 3 minus square root of 3 over 4 square units. Okay, thank you very much.